Hi dear students, I hope you all doing well. अब तक जितने भी हमने discussions की है so far we have discussed about the what are aromatic compounds and उसकी examples, its chemical reactions and so on. In today's lecture, I will talk about I will give you a very brief um, introduction about the anti-aromatic and non-aromatic compounds, because so far we didn't discuss about these two kinds of compounds, though we have discussed a lot about the aromatic compounds. So let's move to the main chart. If you remember, in the previous lectures we discussed about the conditions required for a compound to be called aromatic, and these were four conditions. The first one is the molecule should be cyclic in structure. Second one is the molecule should be planar, means every single atom species in that particular molecule should be in one plane. Third one is the molecule should have conjugation, means alternate double bonds. The fourth one is should follow the Haeckel rule. 4n plus 2 is equal to pi electron. Now you can see on this screen, for anti-aromatic, the only change is in the Haeckel rule. In aromatic, on the left side of the screen you can see the Haeckel rule is represented by the equation that is 4n plus 2 is equal to pi electrons. But on the right side you can see there's a bit changes in this equation. Now for anti-aromatic, the Haeckel rule is 4n is equal to pi electron, with the value of n should be 0, 1, 2 and so on. That in fraction it means. Let's study the case. You can see aromatic compounds. The case study is benzene. It is an aromatic compound because it fulfills all the four conditions that are required for a compound to be called an aromatic compound. It is cyclic in structure, yes. Close. Planar, yes. Each and every carbon is sp2 hybridized. Conjugation is there, yes. And it follows 4n plus 2 is equal to pi electrons. In this case, you can see we have 6 pi electrons because in each pi bond we have 2 electrons. So how many electrons are here? Pi electrons, basically 6. So you can put 6 electron. So when you do calculation, you will get the answer what? 1. So it is an aromatic compound. Okay, let's move to the right side of the screen where you can see a Cyclo Butadiene. Again, it is cyclic in nature. Now what I am saying, it's purely the definition of anti-aromatic compounds. The anti-aromatic compound should be cyclic in structure, it should be planar, it should have conjugation, and it should follow the 4n is equal to pi electron rule. Let's discuss. The case study is this one. Now you can see this cyclobutadiene. It is cyclic in structure. Yeah, it is. Okay. It is planar. Yes. Every carbon is sp2 hybridized. Okay. And it shows conjugations. Yes, it is in conjugation. You can move the pi bonds. These two pi bonds can shift to the up and down positions. That would be the resonating or conjugated structure of this compound. But now Is it follow the 4n plus 2 is equal to pi electron? No, it is not obey that equation. It is indeed following the 4n is equal to pi electrons. You calculate for it. Here we have 4 pi electrons, so 4n is equal to 4 electrons. So 4 को यहाँ लेके आएंगे, so again you will get well, n is equal to 1. But as it follows the 4n is equal to pi electron rule, so that's why such compounds are called what? Anti-aromatic compounds. If it follow the 4n plus 2 is equal to pi electron, it will be called aromatic compound. So this is the main difference between aromatic and anti-aromatic compounds. Aromatic compounds follow 4n plus 2 is equal to pi electrons, while the anti-aromatic compounds follow 4n is equal to pi electron. The other three conditions should be same for both. What are non-aromatic compounds? Non-aromatic compounds other than these compounds are called non-aromatic compounds simply. Like, it is not necessary the structure should be cyclic. It contains sp3 hybridized carbon. Simple examples are methane, ethane, propane, alkane, alkene, alkyne, any cyclic alkanes, and so on. So these are non-aromatic compounds. वो बहुत आसान था उसको पढ़ना, ठीक है. ये दो भी मैंने आपको समझा दिया है. अब लेट्स मूव टू द मोस्ट इम्पॉर्टेंट पार्ट. लेट्स चेक दीज कंपाउंड्स. अब हम अपना इम्तिहान लेना चाहते हैं. I have given you 15 examples on this slide, and you have to identify these compounds whether these are aromatic, non-aromatic. For example, I will address two compounds in these 15. So let's discuss the first one, this benzene, because cyclic, yes, conjugation, yes, planar, yes, and 4n plus 2 is equal to pi electron follows, yes. So it is aromatic. The second one, again, cyclic, conjugation, yes, and planar, yes, because when carbon carries the positive charge, it becomes planar, okay, sp2 hybridized. So what about the n? Yes, in this case 2, so 2 minus 2 is equal to 0. 4 को यहाँ लेके आए, so it would be 0, so it follows Hacker rule. So again aromatic. ये जो बाकी कंपाउंड्स है आपने खुद करने हैं. मैं एक करवा देता हूँ आपको. ओके, नन एरोमेटिक कंपाउंड करवा. फोर्थ नंबर कंपाउंड देखिए आप. In this case you can see the compound is cyclic in structure, yes, and planar, no. Not every carbon in this compound is planar, because you can see we have two carbons that are singly bonded with each other. कोई pi bond नहीं है. These carbons are sp3 hybridized, so बात ही ख़त्म. So it will become what? Non-aromatic compound. बाकी जितने भी compounds हैं 15 तक, so आपने खुद करने हैं और फिर आपने comments box में इसके आंसर लिखने हैं. So then I will reply और फिर मैं अपलोड भी कर दूंगा इसका आंसर. बट इट शुड बी बेटर कि आप उस पर ख़ुद प्रैक्टिस करें. इन कंपाउंड्स को आपने ग्रिप कर लिया तो डेफिनेटली इन यूर एंट्री टेस्ट फॉर द मेडिकल इंजीनियरिंग आपके लिए बड़ा इजी होगा इंशाल्लाह. कोई प्रॉब्लम नहीं कि अब आप इतना पढ़ चुके हो एरोमेटिक और एंटी और ये नॉन एरोमेटिक कंपाउंड्स को, सो इजी होगा इंशाल्लाह इसको कवर करना आपके लिए. सो बेस्ट ऑफ लक. थैंक यू सो मच. ये कंपाउंड आप बस जहन में रखिए, ठीक है. ओके, थैंक यू.